Hey, physics friends. Today we're going to talk about how do you make a measurement. And it seems really ridiculous, and there's a little bit of a caveat to all of this. Making an accurate measurement is the foundation of science. Like, we don't believe anything in science unless we can measure it. What can you measure? So, just to give you an idea of what I mean, I took pictures a while ago of all sorts of measuring devices. This is a thermometer, right? And this was the mercury, or it's not mercury anymore, it's alcohol, inside of the thermometer to measure temperature. You've maybe seen one of these before. This is a beaker. Or an Erlenmeyer flask. Gosh, having a brain fart right now. It's definitely an Erlenmeyer flask, because the beaker's the one that's completely vertical, like a cup. A graduated cylinder. You know, this is a triple beam balance. This is a caliper, a dial caliper. You know, it's got this dial on it, and there looks like to be numbers right here. So in science, we do measurements with devices all the time. And how do you make an accurate and precise measurement? So I'm going to talk to you today about how to do those sorts of things. So number one, the step to reading a metric, I don't want to say ruler because those weren't all rulers back there. They all had the same idea behind them. First step, you have to look and see what numbers are printed on the device. Is it the thousands, hundreds, tens, ones, tenths, and so on? Let me just go back to those pictures and give you an idea. So, for instance, the beaker. These are the 100s, so there are hundreds printed on this thing. This graduated cylinder looks like the tens are printed on it. 10, 20. This ruler, this is the 1. Every 1, 20, 21, 22. The printing is going up by ones. This thermometer, they're going up by tens. So the first thing that you do is you identify what's printed on the device. And then there's a really important question. Does it have 10 divisions between each number? Because if it has 10 divisions between them, then you can measure 2 to the right of what is printed. If there are not 10, then you can only go one place to the right of what's printed on the device. And this will maybe become clear with the examples that I'm about to show here. So I have 6 different measuring devices, and I've got this blue box, and I'm going to measure this blue box on all 6 of my devices here. So number one, I want to make sure it's lined up with 0 to the best of my ability. So that looks to the best of my ability. So, question 1. The ones are placed here, so I'm going to say it's 6. It's definitely between 6 and 7, so it's 6. Now, because there are not 10 divisions, right? Are there 10 ticks between each one? No, there's not. Then only go one place to the right of the printed number. So here I'm going to say 6.2. Yeah. This is a rounding. I would accept 6.1, I would say 6.3, but you do your best. To me, that didn't look like a third, and it definitely didn't look like a tenth, so I went with 0.2. That's my best guess. Let's do the next one. Line it up with 0. So what's printed on here? The 100s. So this is definitely 200 to start with. So 200. And there are 10 tick marks, so I can go 2 decimal places. It looks like 290 exactly. Now, I can't leave it like this. I can't say 290 because that's not showing that this is significant. And I can't go 290.0 because that's too far to the right. Here's where significant figures come into making a measurement. I'm going to say 2.90 times 10 to the second power. This is a little bit of formatting on my end here. Just going to drag this to, whoop, like that. 2.90. So this shows that there are 3 decimal points of significance here in this measurement. 290, and the 0 is important. Here's another one. Make sure it's to 0. Oh boy, look at that. So this is, I'm going to say 30. The 10s are printed, and there are 10 tick marks, so I can go 2 to the right, so 30.0. Look at here, I did not have to use scientific notation in doing this one because it was 10s, and then I can go 2 to the right, so I can go the 1s and the 10th place. 1s, and so it's 30.0 is the correct measurement for this one. Again, 29.9, 30.1, it's all up to the, but this last one is a guesstimate that is up for debate, but it is not, it will be 3 decimal points. That is, okay. Let's line this one up. This is, I'm going to say 30, but then this does not have 10 decimal points in between. There's not 10 tick marks, so I can only go 1 decimal point to the right. So 32, 34, 36. So the question is this closer to 36 or is this closer to 37? I'm going to go 37 because I feel like that's closer to the middle of that than it is to the left. So again, I would accept 36. I would not accept 38 because it's definitely closer to 36, 37. Next one. Okay. 0.3. So it's 0.3 for sure. And now there are 10 divisions. So 0.308. That's mine. It's definitely, I have to have the 0. 0.30 is non-negotiable because it's not to the 0.31 yet. But this third one, 0.307, 0.306, 0.309, that would be negotiable if you were to put this measurement down. So 0.308. And then my final one. Oh, let's see. 0.3. Now, there's not 10 tick marks, so I can only go 1 more decimal. 0.32. Is that right? 2, 4, 6, 8, 10. Yep, 0.32. So I've got some for you. Now, in summary, remember, look to see what numbers are printed on this thing. If there are 10 divisions, then you go 2 to the right. If there are only not 10 divisions, then you can only go 1 to the right. So let's give you a chance to try some. So I've got some for you here, and we'll give you a go. Now, feel free to flip back and look at my examples if you want. You don't have to put your answers in. You can go back and check before you put your answers in, but you're only going to get one chance to see if you understand this. So here's your first one. If it goes right there. How long is this? Question 1. Question 2. How long is this? Question 3. How long is that? Question 4. How long is that? What measurement is this? Question 5. How long is that? And question 6. Final one. How long is this guy? Now, again, in summary, throughout the year, you are going to see lots of measurements, right? It could be a thermometer. It could be a triple beam balance. But the important thing is, look at, this goes to the tenths. There are 10 things in between it, so this is going to go 2 places. So this is actually going to measure to the 1,000th of a gram, which is pretty accurate if you think about something measuring to the 1,000th of a paper clip. That's pretty accurate. I mean, these things, 25 point 0.05. That's to the hundredth of a degree. You know, these things could be very accurate if you treat them as such. This one, again, here's 800, here's 900, so 820. This doesn't have 10, so you have to be careful. Some things are meant for accuracy, like a graduated cylinder, because there are 10 things in between it. Some are not, like an Erlenmeyer flask. Happy hunting, kids. I hope that you got this. If you don't have, if you didn't understand it, please feel free to ask me some questions, but I look forward to working with you in your measurements from here on out.